This is the second video in our series on our booklet of solving algebraic equations. All right, so on this page, we are going to be looking at bridging our hands-on equations, notations, and manipulatives with algebraic notation. Okay, now, whether you're using your hands-on equations manipulatives or you're using algebraic notation, the same idea is that you are trying to figure out what is the value of the pawn and what is the value of the variable. It's the same exact thing. It's just one, you're thinking of it like an object or a symbol, and the other one is an algebraic symbol or an X or a Y, so that variable. But it's still that same process. So all of your logic and reasoning you used here, you're going to use here. We're just going to now learn the correct algebraic notation or the mathematical notation. Remember how at the beginning of this unit we talked about how algebra is like a language? So we are going to learn how to write that language. Okay, so if we were to have a setup like this, go ahead and draw this along with me. Okay, so we have two little pawns and then a 5 number cube. And on this side, what if we were to have a 13 number cube? Okay, so over here, what does that look like as an algebraic equation? So we would have these two pawns are represented by 2x, okay, because it's the number of pawns that you have. 2 is our coefficient, x is our variable, and then we are going to add to that a 5. And then I'm jumping onto the other side of my balance scale, which is going to then be the equal sign. So everything on this side balances with everything on that side, right? That's how an equation works. Everything on this side of my equation balances with everything on that side is equal to 13. Okay, now, if I am using my hands-on equations, what I'm going to do now is I'm going to think, how can I figure out the value of the pawn? I can simplify this by removing a number cube from both sides. Remember my legal moves, if I take away 5 from both sides. So I would do that by crossing it out. Remember this notation? So I'm removing that 5 and I'm removing 5 from that 13, which leaves me with 8 on this side. Now, the way I would write that with algebraic notation is I literally write take away 5 from this side and take away 5 from that side. So minus 5, minus 5. So that's what I'm doing. I'm taking that away. So notice how it's a plus 5. I do the opposite operation, minus 5. Okay, and I'll go ahead and write a line across. So what am I left with? Okay, so let me go back over here to our hands-on equations. So that 5 is gone and I'm left with an 8. So what you're gonna see here are just your two pawns. And then you have that 8 number cube. All right, so what do we have algebraically? Well, this term has been eliminated. So I can just bring down my 2x. That term is eliminated, is equal to, and all I have is 13 minus 5, which is going to be that 8. So you can see how this matches that. It's the same thing. Okay, now my next step, when I have the hands-on equation step, is I think, okay, if I have 2 pawns over here, and that balances with 8, in order to figure out the value of one of those pawns, I'm going to think I have to divide that by 2, right? Because I have 2 pawns, but I only want the value of 1 pawn. So I'm going to divide that by 2, which means I have to think I divide that side by 2. So if I'm going to divide that by 2, I'm going to get 1 pawn. And I divide that number cube by 2, I'm going to get 4. So I know that 1 pawn equals 4. Okay, so how do I notate this thinking, divide by 2 because I have 2 pawns and I want value of 1? How do I notate that here? I literally write divide by 2. And what I do to one side, I have to do to the other, divide by 2. So that's where you get, this is translated there. Notice how I'm using divide by, I'm using the symbol of the fraction bar, which is in essence a division, another division symbol. So 2x divided by 2 is the same thing as this, mathematically speaking. So what am I left with? I'm left with 1x. So if I have 2 x's and I divide it by 2, I'm left with 1x. And that is equal to, I have 8 divided by 2 is going to give me 4, just like I had over here. So what does that mean? The pawn is equal to 4. Now I'm always going to make sure, even when I'm using my algebraic notation, I'm always going to check my solution. Check your solution. Okay, so don't forget. So the way that we do that, remember, is that you take what you think that the variable is. So we think it's 4, and we are going to plug it back into the original equation. So I'm going to rewrite it. 2 times 4 plus 5 equals 13. Now, if this remains a true statement, we know we have the right variable, or the right value for a variable. So 2 times 4 is 8. And then I'm going to bring down 8 plus 5 equals 13. And then I have 8 plus 5 is 13. Oops, I'm running out of room here. 13 equals 13. Is that a true statement? Sure is. So check, I got it. So x is 4. All right, so that is how algebraic notation is connected with our hands-on equations.